Bye-bye.
Bye. Good morning, grade sixes. Welcome to STEM Lockdown Digital School. We are doing natural science and technology. I'm your teacher, Sheena Cooney, and I am so happy to see some familiar faces. Welcome back. I got a lovely email from one of the students yesterday asking for some notes. So thank you for that. So just to let you know, I am busy putting together some notes about what we've been learning. They are not finished yet because I have to do them in a way so that if you ever get to print them, it saves ink as well. So that's quite important. And it needs to be a bit readable because the notes as they are not as clear as I'd like them to be. So I'm working on that for you, and hopefully I'll have it ready for all of you by the end of this week. So I am working on that just to let you know. So today we're actually going to continue with our lesson from yesterday. Okay, so we are going to, as I said to you, we're probably going to repeat the same thing of what we are learning because it's all around the same topic. Okay, we're just continuing with it. So this is kind of what we started with yesterday, some of what we started with, the meanings of a mixture and a property. Okay, so mixture is when you mix two materials together and you can still see the two separate materials. All right, a property is a characteristic of an object, so you can recognize it by its shape, its color, its size, its texture, and so on. All right. This is also, we managed to, I think this is might be around where we also stopped to explain. And we discussed a few examples of a solution, that it's a special mixture formed when a material dissolves in water. Now remember, solution has to be clear. Mustn't be like bits and pieces in it. Okay. Dissolving is when one material dissolves into another, so it blends in with the other so that it becomes transparent, so you no longer see it. Okay, so it becomes one with the solute, becomes one with the solvent. All right. Elements is just a word that's going to come up, and it's something that cannot be made or reduced into a smaller substance. And I gave some examples of the Earth's most common elements that we looked at yesterday, such as carbon and oxygen and nitrogen, hydrogen, magnesium, gold, aluminium, and copper. Okay, and then I also put in a little link there that you can go and look at the video. I actually found 2 songs on mixtures. We can't, they're not songs that I can play. They're actually just lyrics, words of songs. But you can also like kind of read it like a rhyme and make your own tune to it to kind of help you remember when you're doing an assessment or a test or in the future. Welcome, Blessing. I'm just going quickly over what we ended with yesterday. Welcome to our class today. So this is kind of what we introduced yesterday about mixtures. All right, that mixtures can be heterogeneous or homogeneous. All right, so a mixture is a combination of 2 or more substances and there is no chemical reaction. A heterogeneous mixture is different to a homogeneous mixture. All right. Heterogeneous means that you can see each of the components. All right. So when you mix the mixture together, you can still see, for example, if you mix rice and barley, you can still see the rice and barley particles. Homogeneous mixtures, you can't really see the components separately. Okay, I do have a better example on the next slide. I actually do think this is where we stopped yesterday. Okay, this is the nice example I gave you yesterday about a mixture. I really liked it because it put it so nicely, the example at the bottom there, and it kind of stands out with the colors. So I thought it was a really, really nice example to show you, although you do know this quite well. Mixtures of liquids. Now, as you can see, oil is on its own and water is on its own, because if you mix oil and water, they don't really mix. Okay, so they don't actually blend in and dissolve into each other. All right, so that's why they're separate in this one. However, you can mix a concentrate to a liquid to make juice, and you can mix sugar to coffee to, well, apologies, coffee powder to hot water to make coffee. All right. We did our mixtures of gases. I got some nice suggestions for the different kind of gases that you can mix together. Do you remember what they are? Which gases can we mix together? I got a few suggestions yesterday. Where's Michael? Is he here today? Is Michael here today? Not here today. Okay. All right. Okay, so who wants to type in the chat there which two gases can actually be mixed? Any ideas? Welcome. I'm just glad you're here. Welcome to our class. It's okay if you're not that late, so it's all right. Hydrogen and nitrogen, oxygen and nitrogen. Yes, they can be mixed. If you remember, welcome, nice to have you here. If you remember, I was talking about in one of our lessons about diving. You know, when you go diving, you have a mix of gases in your tank so that you can breathe underwater. And those are actually quite a number of components of gases. Okay, there's oxygen, there's nitrogen, and they are the main two gases in your breathing tank. We have others. We have helium, and we have carbon dioxide, and we have carbon monoxide. Okay, and most of those gases can mix together. For example, the air that we're breathing isn't just oxygen and isn't just nitrogen, but there's also water vapor. There is also carbon dioxide from the greenhouse gases. They're also present in small amounts, okay? And you can't see them because they blend in with the air. And gases, as you know, we can't really see very well. All right, so this is the example. Some of you, we were on yesterday, you were jotting this down, the two types of mixtures. I really like this example because it gives you a nice meaning. For example, heterogeneous refers to different, so you can see the different parts. Homogeneous means the same, so you cannot see the different parts. Everything looks the same. So I just thought it was a really, really nice example, especially for learning. So I don't know if you want to jot that down. If you already have it, it's fine. We can move on to the next slide. It's not a problem. You just let me know if you want to write this down. Now, the notes I'm giving you aren't going to be exactly like this, okay? They're going to be a bit more detailed, all right? So if you want to have these notes as simple notes, you can do that, all right? Okay, so most of you have the notes because we did do it yesterday. If you didn't, you can get it on our website and you can get the PowerPoint there as well. So here's some examples of our different mixtures that we discussed yesterday. Okay, now what we have here is a few more examples. All right, it's always nice to have more than one example. Homogeneous mixtures are like your liquids and your gases. Okay, and heterogeneous mixtures are like your solids, or mostly your solids. As you what was nice about, I think Michael mentioned it in the first lesson, he said the actual names like solute for solid and solvent for liquids. Okay, so I'm going to stop here if you want to take these notes. Now, Kiara, these examples, heterogeneous and homogeneous, are the same as on the previous page. So you don't need to rewrite these because you already have these ones. Remember, we wrote I've just put them on this page to put with our examples. So I think you already have these two meanings. But if you want to write them down anyway, you can. I don't mind waiting. Okay. All right. Blessing, are you busy writing that down as well? Okay. So I'm going to just hold you for just a wee minute so that you can write that down. Okay. Welcome, Buntlu. Nice to have you. Okay, so, okay. I think Kiara might still be jotting some of this down. Bonte, do you want to write this down or are you good? Because I know we did have it up before. So if you have these notes, it's fine. Yes, you can write it down. Or I can put it in a worksheet for you. Because I'm working on a worksheet for you guys. But this is a simple example. So I'm going to give you 1 more minute. Okay, I'm going to give 1 more minute for you to write this down. And then we need to move on. Okay. I'm actually going to type in my email address for all of you so that if you want to ask me any questions, if you also want me to email notes, email me so that I can email it to you. If you have any questions or if you need anything or if you have any work you want me to see, send it to my email address. Okay. And I will attend it. All right. Just remember also, when you do email me, I teach more than one grade. So remember to tell me that it's for grade 6 natural science. All right. Because in some of my lessons, there are some names that are similar. So I might not know exactly which grade and which subject. So please always include which subject and which grade when you send me your work or you send me a question. Okay. Then I can put it in a folder and I will remember. It's okay. Welcome. Nice to have you here. All righty. So now, welcome. I'm just glad you're here. I don't mind if you're a little bit late. At least you arrived. We're just reviewing what we did yesterday. So you haven't missed anything. Now, this is a note you do need to take down. Okay. Solutions. A solution is a special type of mixture. It's a homogeneous mixture that combines a solute and a solvent. Would COVID-19 be a heterogeneous or a homogeneous mixture? Well, now that is a very interesting, it is a virus. Can you see it? Okay, so in this example, a solution involves one substance dissolving into another substance, which is usually a liquid. All right. Now remember that the virus that you've asked the question for about, okay, has little particles, like for example your saliva, and it does spread in tiny little liquid particles, and it does spread in the air. So a homogeneous mixture would be one that looks the same. Okay, and a heterogeneous, it would be looks different. So I would say, if one had to be really particular, I would say it's a homogeneous mixture, because everything looks the same. You can't really tell the virus from the air. Okay, you can't really see it. All right, so it might be, yes, it's a homogeneous mixture, yeah. But that's a very good question, by the way, I have to say. Very good question. Well done. Thumbs up for you. Very good question. Okay, let me know when you have these notes done and that whether or not I can go on. Okay. How are you doing, Kiara? Alrighty. Okay, so this is a very nice diagram for you to actually draw so that you can visually understand how to make a solution, what a solute and a solvent is. Okay, now it is very, you could just write solute plus solvent equals solution, but it's always good to have a visual idea. All right, so as you can see in the top, there's a solute and a solvent, and when we mix it together, it becomes a solution. For example, salt water equals solution. All right, now Talia has asked me to go back. So I'm just going to go. Talia, are you going to write it down? Okay, we've got a few requests to go back to the previous one so that those who arrived a little bit late would like to write it down. For the rest of you, thank you for your patience. I really appreciate it. I hope you don't disappear on me. Stay with us. We just want our peers to be able to jot this down. It might be the only way that they can get the notes down. All right, so I really appreciate it. I think this is the most patient class. So thank you so much for being so supportive and for giving everybody a chance to do what they need to do. So what I can do as well is I can write it, but it probably won't look as good. Okay, wait. All right. Okay, so what I'm going to do is I see that you've got this done. So now we can go to our next page, which is how to make a solution. So we use a solute and we use a solvent. Then you can also write down the definition. I think you need to, it's a simple definition, but I think it's good to have it. I know some of you are busy writing it down now. I'm going to try and help you by typing it also in the block, just so that you can have it there as well. And I'm going to give you a wee example if you like. So we can put that here. Oops. There we go. Alrighty, does that help a little bit? Okay, and then the last we note is the liquid part, which is the solvent. Alrighty. Okay, so do we have that? Okay. So now what you need to also do and remember is that you could be asked to actually draw the diagrams. So that is why I'm presenting you also with pictures, so that you can also see if they ask you to draw it or if they ask you to identify it, you at least have the imagery for it. Okay. Now going on to the next one, we have something we call solubility. Okay. Now solubility, soluble tells you that something is a soluble, which is, who can tell me what soluble, if you had to describe it in its basic form, what would you say its meaning? I know I have the example up here, but in your own words, what would you say? Something that can be dissolved. So it is something that is soluble, is like a solid, right? Is that right? You agree with me there? Okay, so it is, you take a solid and you put it in a liquid so that you can dissolve it. Very good. It's a form of measurement. All right, so something can dissolve quickly, something can dissolve slowly. All right, for example, if you put salt, and remember what we talked about, agitation and stirring and temperature, etc., to dissolve something. Now, even if you abided by the rule of temperature, agitation, etc., even if you abided by those rules, the more solute you add, it's still going to take longer to dissolve because it will have low solubility. It'll be denser. So it won't dissolve easily, even if you use the same method that you used for a small amount of salt or something. Sand is naturally dense, okay? So even if you use a small amount, it still does not dissolve easily. It has low solubility, okay? Now, if you are finished writing this down, just give me a thumbs up or a yes, you're done, so that I know we can go on to the next one. Okay. So let me just help everybody a bit here. No, that's not working for me. All right, so we've got high solubility, so this is an example of high solubility, and then I'm going to add in low solubility, because at least you can save these chats and you can see the examples later if you don't get them all down or if you forget something. All right. So there you have your high solubility and your low solubility and an example in the chat box as well. Okay. So now we're going to go to our next slide. Right. Dilute versus concentrate. All right. Now, dilute is, for example, you can add a little bit or a lot to a solute. For example, you can put spoonfuls in a cup of tea. You can put a small amount. You could put a large amount. Okay. The more solute there is, the more concentrated it becomes. The less you use, or the more liquid or solvent you add, it becomes diluted. Okay. So dilute is when you add more liquid, and concentrated is when you add more solute. I've typed it in. Can you see the chat box? I've typed the previous page's notes on the chat box. Can you see that? Okay. Because then at least you can copy from there. All right. Okay. So do you want me to also put this one in the chat box? Okay. So I'm going to see if I can add this into the chat box for everybody because it seems to help. If I can help you, it's what I'm here to do. So a concentrated is when you add more solvent. So that would be your liquid. Oh, what do you have here? Okay, does it help if I type it in the box? Okay. I don't want to do it if you're all like, ma'am, you don't have to do that, you know, wasting time. But if it helps you, or looks a lot when I type it, but when on the page it doesn't look a lot. Zainab, is that your? See, you've sent me it twice. Your holiday work. Welcome, glad you're here. If you just look on the, I don't know if you can see the chat, Melody. I have put up some of the information that's on the screen, but if you want to write it down, you can write it down while we are here. On the next page, we are going to actually have a look at a few more examples of this. Now, I know that sometimes we forget maybe what a solute means and what a solvent means. All right, so it's always good maybe to write in brackets next to solute, solid, and next to solvent, liquid. Okay, all right. Now, Kiara, why don't you email me and just so I can get your email address that way, it's much easier. And then I can send you some notes. Would that help you? Okay. And it also helps with the writing if you don't get everything down. Okay, sweetie. Okie dokie. Shall we go to the next slide, or are we still busy? Okay, so we still, Bonte's still busy, so we're going to, but you can actually try this at home when you're making a cup of tea, if you if you're allowed to. You can actually test this theory. But I'm sure you've made yourself juice, haven't you? Where you've got OROS or you've got Energade, concentrate, and you've had to mix it with water. And you will find that the less water you use, the sweeter and stronger it is. But the more water you add and dilute it, it becomes more perhaps tasteful and less sweet and less strong when you dilute it. So yeah, we have a few examples for you. We have this goes with the previous example. So if you, for example, putting spoonfuls of sugar in a cup of tea, a solution with a large amount is called concentrated. Okay, so if we're just adding lots of solute into it, it's going to be very like, not as much liquid, let's put it that way. Okay. Now, a saturated solution actually can't hold any more water. So, but remember, it does say only at a certain temperature. So the more you add to your solution, the more solute you add, eventually becomes saturated. And it becomes like really like dense. Okay. And the only way to get it to actually become a solution is to add more liquid and dilute it. So a saturated solution is a solvent that cannot take any more or absorb any more solute. But remember, it does say at a certain temperature. Okay, so if I had to take that solution and I had to heat it up at a very high temperature, then it might still manage to take it and dissolve it. But at certain temperatures, especially room temperature, it won't. Okay, so a few of you are taking notes, so I'm going to stay on the page for a minute so that you can jot this down. I'm still here, I haven't gone anywhere, so don't worry. Has anybody tried these experiments and videoed them? Because if you have gone onto Flipgrid recently and done that, you must let me know, because then I can go there and have a look. But I'd really like to actually see you, if you have done the experiments, to actually see you record it, because that would be really cool. And if you don't mind, I can share it with the class as well. I like to make a fuss of those of you, if you have the time and the opportunity. We're not all able to do this, okay? Some of us are not able to take recordings and upload it and send it, and I completely understand. But if you do, it would be really, really awesome to see. But it's not compulsory, and you shouldn't feel bad if you can't do it. But it is nice for me to see what you are doing as well. All right, now to make it supersaturated solution. All right, it contains more solute than it can normally dissolve, so you need to heat it. Okay, so by heating a solvent up, we can make it hold even more solute than normal. So you heat up your liquid, and as I explained in the previous slide, this is what I was explaining. If you heat it up, you can add more. So by heating a solvent up, we can make it hold even more solute than normal. A supersaturated solution contains more solute than it can normally dissolve. So, but by heating it, you can add more. Okay. Do you need to write this down? It's okay if you can't. Really, it's okay. It's just if you can. Okay, so I see that. Are you still busy with the previous slide? I see some of you are still busy with this one. Okay, all these slides actually go together. They step by step. Okay, so in the first one, we add solute to a solvent. All right. In the second one, we add more solute, and then the solution becomes saturated and it cannot dissolve at its current temperature. And then on the next slide, we realize that by heating it up, we can actually add even more solute to the solvent. For those of you that might have come a bit later in the lesson, you might have missed me typing my email address that you can send questions or ask for notes. So I'm just going to type it again, for those of you that might have it, and you can email me and I will send you notes. Okay, are we still busy with the slide? Don't worry, there's no rush. I just want to make sure. So for interest sake, just because I'm curious, who is drawing the picture? If you want to send me things, you can attach it to your email and say email me, or you can go to Flipgrid. I'll show you in a moment how you can share it on Flipgrid. Did you draw pictures? That's awesome. I'm a very visual person, so I need pictures. I'm going to explain to you now what Flipgrid is. Okay, we will just do another slide and then I will explain to you about Flipgrid and how you can use it. Yes, yes, yes. Okay, so here's your super saturated solution. I know some of you are still busy writing this down. So Flipgrid is, you go into Google and you basically type in www.flipgrid.com. You go to grade 6 NST, Natural Science. Okay, and we created our own code as a class. I do have it on the slide, so I'll scroll down just now so that you can all have it. Okay. Yes, there is an app as well. But I'll show you now. Okay, let's just first complete this slide and then we'll go to the example of the Flipgrid. Yes, you can use your computer. Okay, there we go. Melody's got the flip code. Okay, so what I'm going to do quickly is I'm actually going to flip through quickly, don't stress. Over here, where is it now? I'm sure I added it yesterday. Ah, it's not here. Okay, that's not cool. All right. So, yeah, no, you can't see the code. Let me see if I can show it to you. All right. So what I'm going to do is I'm going to go to, let's see. I'm going to type it in here. So you go to this website. Okay, let me just share it with everybody because it keeps changing the name here. There we go. So you go to this website, you go to where it says enter flip code, then you type in the flip code. All right. Then you will see it'll be actually labeled grade 6. So that will be what it's called. And then you click on the green plus button. And then you record. Super 6, the code is okay. There you go. All right. So then you can record there, or you can just show your work. Okay. If you aren't actually doing a recording. This is the last slide for today that we're going to do. This is some of the definitions. Okay, and an example of what a diluted solution looks like and what a concentrated solution looks like. Okay, so a concentrated solution is the amount of material that you dissolve in a measure of liquid. Okay, it will be the same measure of liquid. Okay, and a diluted solution is less concentrated because you're adding more liquid. Savannah, you've asked me to go back. So I'm just going to, is it this page that you're still writing on? You don't need to introduce yourself on Flipgrid. You can just record straight away or share straight away. Okay, you don't, I know it says say hi and all that, but you can just go straight to our grid and share your work. You can draw, you can do the experiment. It's entirely up to you. Okay, so we've got a few minutes left. So if you want to take anything down, that this is what we've discussed today. So if you want to take anything down, do that now. Okay. And because we've got a few minutes to do that. And then what I do is, I'm not going to say goodbye yet. I'm going to let you jot this down first. Some of them we did, yes, we did have them in another lesson. Remember, we were doing different parts of this throughout. But I just wanted everybody to have the definitions and the meanings in this lesson and yesterday's lesson. So if you do have some of them, it's fine. You don't need to rewrite them. These are just the definitions and the meanings. Okay. I just want to check if there is another slide quickly. Okay, no. All right. Yeah, this is the last slide. The dilute and concentrated we touched on today. So just make sure that you have a good understanding of what that is as well. Yes, you can. You can introduce yourself and you can read on Flipgrid. Absolutely. I would love to know more about you. You can share your experiments. You can share your work. It's a really nice platform and it is secure. I have secured it. So it should be fun. Okay. I want to just say thank you guys so much for joining me today. Thank you for your patience. Thank you for your cooperation. I absolutely love teaching this class. You guys are absolutely amazing. I am going to work on your notes, but I do need you to email me so that I can send it directly to you. Then it's easier for you and you'll have the notes. Okay. So I am putting together notes for you by the end of this week. All right. So let me know if you want them. Love you guys. Have an absolutely awesome afternoon, and I will see you same time.